Welcome to Untitled Academy. This is Richard Tai. We are continuing our trigonometry lessons in this video. Today we're on trigonometry lesson number 39. We have been talking about fundamental relations or trig identities, fundamental trig identities in our videos for several lessons now. So today we're moving on to verifying or proving trig identities. So how do we verify or prove trig identities? Well, what happens here is we have been working on solving, simplifying equations, trig equations, expressions that they have given us. They want us to simplify. In reality, there are so many different ways to simplify our any kind of given trig equations or expressions. But now, this time, they are going to show us, given us an equation and then or a proved equality. Okay, so we know they are equal, and then we want to prove that both sides are the same. So how do we do it? Well, there are several steps. First, we always start with the more complicated side, okay, and then we usually use our fundamental identities and fundamental relations to make substitutions, and we always want to simplify using algebraic reductions like combining like terms, factoring, adding and subtracting fractions. Then, if we couldn't find anything else to do, we can try convert every term and rewrite every term in terms of sine and cosine. And then also remember, we don't want to introduce radicals. Okay, so those are a few pointers that we want to use, but always start with the more complicated side. Alright, so let's take a look at some examples. Okay, so and let me show you we can talk about the so let's have this first example. Tangent theta times sine theta plus cosine theta equal to secant theta. Okay, so how do we prove the left hand is equal to the right? Well, let's do a two-column proof in a sense. Okay, I'm not sure if you have done this back in geometry. Maybe you have seen this. We divided two columns. Okay, so we can transform the right-hand side, left-hand side, and then show that it's equal to the right-hand side. Now, first of all, we always want to start with the more complicated side. So the more complicated side here is very simply the left-hand side here, tangent theta times sine theta plus cosine theta. Is less much complicated than secant. Okay, so now, is there any way we can substitute using our fundamental identities? I think we can. Now, so tangent and sine. So the first thing is, let's replace tangent in terms of sine times cosine. Tangent is sine over cosine, which is our quotient identity. Okay. So sine times cosine over cosine times sine. So that will give us sine squared theta over cosine theta plus cosine theta. Okay, now in order for us to combine these two terms, we have to have a common denominator in the fraction. Cosine has a denominator of 1 right now, so we need to have a common denominator of cosine. Okay, the common denominator is simply cosine theta times 1. So we multiply this by cosine over cosine. Okay, so that will give us sine squared theta plus cosine squared theta, and now both of them have a common denominator, which is cosine. So we can write them together in one fraction. Excuse me. So then sine squared theta plus cosine squared theta is equal to 1 by Pythagorean identity, and it becomes 1 over cosine theta, and 1 over cosine theta is equal to secant theta. So we have proved that those two sides are the same. Secant theta is equal to secant theta. So basically, it's kind of like a continuation of what we have been doing. But this actually is easier than before because we actually know where we should end up with. So there's a direction that we can go. Okay, so let's go and try another example here. Alright, so we have our example number 2 here. Let me draw a two-column and separate the two sections here. So we have cosine A over 1 over sine A plus 1 over sine A over cosine A. So those two seems to be very similar, definitely related, and they're fractions. So the first thing is we want to start with the more complicated side, which is the left-hand side. And how can we combine them? How can we make them simpler? Well, we can combine the fraction, but in order to combine the fraction, we have to have a common denominator. Now look at the denominators right now. Okay, here the denominator is 1 plus sine. Here the denominator is cosine. Now they don't have any common factors, so the common denominator would be the product of the two denominators together, which means you just have to multiply them together, right? So let's go ahead and write it out a little bit more. Okay, so that means my common denominator would be the product of 1 plus sine times cosine. So that means I need to multiply by cosine over cosine for the first fraction. And the second fraction, okay, the second fraction I need to multiply by the other denominator, which is 1 plus sine A, okay, times 1 plus sine A. Alright? So this is a basic way of working with fractions. Now we are ready to go ahead and combine those two. So let's go ahead and write the big fractions here. The denominator is 1 plus sine A times cosine A. Now I don't want to multiply them together yet because I want to keep them in factor forms. So maybe later on we can cancel them out. So here, the first term, we have cosine times cosine, which is cosine squared. Now here is something that requires to use algebraic techniques, which we need to use distributive properties, or FOIL in this case. We can use FOIL, but basically we're distributing those two products. So it becomes 1 plus 2 sine A plus sine squared A. Okay, so if you distribute them, 1 times 1 is 1. They have 1 times sine A and sine A times 1, so they're 2 sine A, and sine A times sine A is sine squared A. So that's how you get that. You can go ahead and check, make sure you understand how this comes about. Then we keep going. But let's see what else can we do. I see there's a cosine squared A plus sine squared A. Oh, okay, those two things, if I add them together, should give me 1. So 1 plus 1, that should give me 2. So I have 2 plus 2 sine A, okay, over 1 plus sine A times cosine A, okay. Now we need to go ahead and use all the algebraic techniques that we know of to try to make it to simplify things. And I see that 2 plus 2 sine A can have the common factor of 2, so I can factor out that 2. So if I factor out that 2, I will have 1 plus sine A left, okay. And now it's the numerator is in factor forms, okay. When they're in factor forms, it's much easier to deal with because I see there's a factor 1 plus sine A divided by 1 plus sine A, so those two factors cancel out. So this will become 2 over cosine A, but 2 over cosine A is 2 secant A because the reciprocal cosine is secant. So we have proved that the left-hand side and the right-hand side are the same. Okay. The left-hand side and right-hand side are the same. So that is what we have come up with. Alright, let's try another example. There are different techniques that we can use, but usually it's algebraic techniques and it has to do with fraction. So if you're comfortable with fractions, if you're comfortable with the algebra techniques, you need to, then you will be doing you'll be not so challenged by this. But if you're not familiar with those techniques, it's a good time to help us to review those techniques. Now sometimes, okay, for example like this, okay, it looks like that both sides are equally complicated. So what can we do? Well, sometimes we can actually work on both sides. It's possible to work on both sides. We don't have to just limit ourselves to one side. Now, tangent and cotangent, of course, they are equivalent to each other. Okay, no, I'm sorry, not equivalent. They're related to each other by reciprocals. They're being reciprocals of each other. So there are several ways to approach this problem. Now, one way we can work on this is, how about let's write the tangent and cotangent all in terms of sine, cosine. So this would become sine over cosine minus 1 for the numerator. and the denominator is sine over cosine plus 1. Okay, let's do the same thing for cotangent. Now cotangent is cosine over sine. Is a little bit different, and cotangent is cosine over sine. So okay, so I don't see how they are equal to each other yet, okay, but we can go ahead and come to that conclusion. Now look at complex fractions. The denominator is cosine, cosine. So what we have to do is to remove those cosine. We can multiply both sides, the numerator, the top and the bottom, by cosine. Now let's see what happens. So that way it will become sine theta minus cosine theta in the numerator, and the cosine times sine divided by cosine, the cosine cancels out. So here will be sine theta plus cosine theta, because this cosine times 1 you distribute, so that becomes cosine. Okay. Now same thing here. We can do similar technique here. Look at the denominator is sine, so I can multiply the numerator and denominator both by sine over sine, which is 1. So we're not changing anything. Alright, so sine times 1 is sine, we distribute, and sine times cosine divided by sine is cosine, sine times 1 is sine, and then sine times cosine divided by sine is cosine. So we have proved that the left hand side and the right hand side are equal to each other. Okay, so indeed they are the same. Now this is not the only way that we can do it. I could convert cotangent to 1 over tangent, 1 over tangent, and multiply by tangent, and you will get the same thing. Okay, so it could be easier that way, but there are several ways that we can do this. Let's try a few more examples. Alright, so now remember, there are more than one way to prove this. Okay, there are several ways to do it, but let's take a look at this. Cosine square x plus cosine square x times tangent square x equal to 1. Now one thing I noticed is there's cosine square x plus cosine square x. There are cosine square x in both of the expressions. So one thing I can do is I can factor. Okay, remember, you can treat this as algebraic expressions. They can be factored. They can be multiplied. They can be whatever you can do with algebraic expressions, you can do to them. So I factor out the cosine square x. This becomes 1 plus tangent square x. But I have to remember, tangent square x is equal to secant square x. And cosine and secant, I also remember secant is the reciprocal of cosine, so secant square x is 1 over cosine square x. Okay, and then cosine square x over cosine square x is equal to 1 because they are reciprocals of each other. So we have proved that the left hand side and the right hand side is equal to each other. You could also try and convert tangent square x to sine square x over cosine square x, and cosine square x can cancel out, and then cosine square x plus sine square x is equal to 1. Okay, but there's definitely more than one way to do this. Okay, and I just want to show you that you can factor and you can multiply things. You can do distributive property. There are a lot of things, a lot of techniques that we can do. Alright, so let's try a few more examples here. Alright, let's look at example number 5 here. Cosine to the 4th power theta minus sine to the 4th power theta equal to cosine squared theta minus sine squared theta. Now I want to show you this example because this requires us to do some other techniques. It requires us to factor. Okay, so how do we factor cosine to the 4th power minus sine to the 4th power? Well, if you remember how to factor the difference of squares, that's how exactly we can go ahead and factor the difference of squares. Remember, a squared minus b squared equal to a minus b, right, times a plus b. So that's how we factor difference of squares. So cosine to the 4th power minus sine to the 4th power is cosine second power is theta minus sine squared theta times cosine squared theta plus sine squared theta. That's basically just what that is. Yes, a minus b times a plus b. In this case, I'm looking at this as the square of the second power. So of course, cosine squared theta plus sine squared theta is equal to 1. So the whole expression simplified down to this. So this is a very simple problem actually. We only take 2 steps to get to the answer, and we prove that left hand side is equal to right hand side. change that to green. Okay, but the key is be able to factor. Okay, when you see power, when you see fourth power, higher powers, and then powers like this, it can be factored. Okay, so don't be afraid when you see, oh, let's cosine to the fourth power. Like, what do I do? Well, don't worry about it. You just factor. Okay, you got to remember the techniques that you have learned from previous algebra classes, algebra 2, and things like that. Okay. All right, I think we can try a few more. So this example number 6 here, you have tangent b plus cotangent b squared equal to secant square b plus cosecant square b. Okay, so there are several ways we can approach this. Now we could use the algebraic situations, algebraic approach to convert this to use use FOIL, use the distributive property to expand this term, and then see what happens. We could do that. So let's go ahead and expand that. So when you do tangent b plus cotangent b square, you are basically doing tangent b plus cotangent b times tangent b plus cotangent b. So you get tangent b squared plus 2 tangent b cotangent b and plus cotangent b squared. Alright, so right now it looks like the left hand side has nothing to do with the right hand side, but let's go ahead and see what happens. So tangent square b plus 2 tangent times cotangent, but tangent times cotangent is just 2. Excuse me, tangent times cotangent is 1 because they're reciprocals. So it's 1 times 1, so it becomes this. Now look at the results. The results is secant square b and cosecant square b. Now I know secant square b is related to tangent square b. It's 1 plus tangent square b. Well, actually I do have a tangent square b plus 1 because there's 2 number here. So I could write it 1 plus tangent square b, and I could put this aside. And then there's another 1 left, so it's 1 plus cotangent square b. So we're actually looking at the result and seeing where we want to go, because there are so many different ways to approach this problem. But if we look at the results, if we look at the ending to see where we want to go, then we have the clear idea of what's going on. So I can go ahead and separate that 2 to get 1 plus tangent square b, which is equal to secant square b, because that's from Pythagorean theorem, Pythagorean identity. And then I have 1 plus cotangent, that's equals cosecant square b. So now we're done. Okay, so this is an example that we use algebraic methods, but also we have to look at the end to help us get to the beginning. Okay, alright, so today we have done several examples to show you how to do this. Tomorrow in our next lesson we will go ahead and do a little bit more examples. So please remember to subscribe or share this video with your friends, with your classmates. And if you have any questions and comments, please leave them in the question and comment sections. Hopefully we'll see you next time, and that you will join us with our trigonometry lesson again. Thank you.